Hello everyone, this is 16.2 Factors Affecting Reaction Rates by Come With Me. Okay, so there are 6 factors we're going to talk about today. Reactivity and the nature of reactants, it's another name for reactivity. Pressure, concentration, surface area, temperature, and catalysts and inhibitors. Okay, so for reactivity, there are some elements more reactive than other elements. So when you bring one of these elements into a reaction and it causes the reaction to react more, then that's going to be reactivity or nature of reactant. It's usually adding another element. So if your question has another element that is added that wasn't in the original equation or original reaction, it's reactivity. And this is a reactivity series which sorts elements into more reactive and least reactive. Okay, so concentration. Increasing concentration of reactants leads to increase in reaction rate. Relate with the collision theory that we took previously. It states that when concentrations are increased, more molecules are available to collide per unit volume, and therefore collisions occur more frequently. Let's say that there are 5 girls in a classroom. They're all blindfolded and they run around the class. And of course they're going to hit each other. But when they hit each other, the collision is good. It means that the reaction is happening or allows the reaction to happen. But when you add 20 girls into the room and they're all blindfolded and they all run around, they're going to hit each other more, which causes more collisions, and therefore the rate is increased. So when concentration is increased, collisions are increased, which increases the rate of the reaction. And for surface area, let's use the same example and say that there are 2 huge groups, and inside they're a huge circle, 2 huge circles, and they're both blindfolded, but they're stuck together. But they won't hit each other as much as if you cut those circles in half and allow the girls in the middle to be shown or to be on the edge as well. That means more particles are on the surface, which means that more collisions will happen because you have more surface area. So for the same mass, many small particles have more surface area than one large particle. Like a carrot. When you cut a carrot up, you see more sides, if that makes sense. Which means you see more molecules on the edge. Reaction rate increases with increasing surface area, and when you relate it to the collision theory, greater surface area allows particles to collide with many more particles per unit of time. So when you hear dust or explosions or small particles or cuts, these are all keywords for surface area. Temperature. Increasing temperature increases reaction rate. When you relate it to the collision theory, you relate it 2 ways. The first way is that it increases the kinetic energy of the particles, which increases collisions. And the second way is that reacting particles collide more frequently at higher temperatures. Higher energy collisions are more frequent at a higher temperature. So let's use the same room example and say that we have 10 students in the room, both blindfolded, both running around, not knowing where the direction is. again, they're going to hit each other. But what if they're going even faster? If they're running around really, really, really quickly, they're going to, again, hit each other more. That's what temperature has to do with this. And they collide more at a higher temperature, which increases the rate. Okay, catalysts and inhibitors. A catalyst is a substance that increases the rate of a chemical reaction without being consumed in the reaction. That means, unlike the nature of reactants, it's not a part of the reaction. Like, it's not an element in the reaction. It's not added to the reaction. Okay, it's added to the reaction, but it's not consumed. They work by lowering the activation energy. In the previous lesson, we said that the higher the activation energy, the slower the rate. So here, catalysts work by lowering the activation energy. And it means that more of the collisions between particles will have enough energy to overcome the activation energy barrier and bring out a reaction. Let's use the same room example. Let's say that even when the particles are running around and hitting each other, there's this, let's say, referee or man that's taking them and forcing them to hit each other, forcing them to collide, or forcing the reaction to speed up in a way. And that's a catalyst. It's not used in the reaction. It's not hitting anything itself, but it's forcing two things to collide. It doesn't work that way, but think of it as way. It's not consumed into the reaction, but it helps the reaction go quicker. An inhibitor is a substance that slows or prevents a reaction, and they work by blocking lower energy pathways, which raises activation energy, or reacting with the catalyst and preventing it from working or destroying it. A heterogeneous catalyst exists in a physical state different than that of the reaction it catalyzes. An example of that is a catalytic converter in cars. And a homogeneous catalyst exists in the same physical state as the reaction it catalyzes. Example, using potassium iodide solution to decompose hydrogen peroxide. So hetero, know that it's the different physical state, and homo, know that it's the same physical state. And that's it. Thank you so much for watching, and I hope this helped.